All right, so welcome to ACT Prep Day 15. Everybody should have your bell ringer, and no, I do not want to be annotating, sorry. Little glitch here. So your bell ringer, this is adding and multiplying fractions. Again, if you are terrible at fractions, I cannot stress enough, invest in a calculator. You can show this to your parents. If they do not believe you that I say this every day, have them watch this. It is worth the investment. Highly recommend the TI-84 is worth $100. Every one of my kids have one. But the TI-32S at $10 does fractions great. Oh my gosh, it really does fractions amazingly. And again, yeah, fractions are hard for some students. Yeah, so pause the video. I want you to work on these, adding and multiplying, dividing fractions, and the reciprocal. And then when you're done, push play again, and we will double check your answers. All right, so welcome back after doing those problems. And let's look at this. Adding and subtracting fractions are my least favorite of the fractions. I would much rather multiply and divide because actually they're easier. Because the problem with adding and subtracting fractions is you got to have a common denominator. Yeah. Here the common denominator would be 6. So if we did this, it would be 2 6 plus 3 6. So the answer is going to be 5 6. Yeah. Here, the common denominator would be 35. Yeah. So what's that going to be? 21 35. It's really hard to write with this pencil. And then that would be times 5. So what is that? 20 over 35. Yeah, so 41 35ths, and you always want to put it in simplest form, and your calculators are really great because if you do 41 divided by 35, math enter on the TI-84, or whatever you have to do in the TI-32S to put in a fractional form, it automatically puts it in simplest form. And you can see here, oh good, they already did it, common denominator. 1/3 can be 3/9 common denominator. It's already in simplest form. 1/4 can be converted to 3/12. We get 1/6. Now multiplication, I love multiplication because again, you can just multiply the numerators, multiply the denominators. Now one thing I feel like they have neglected teaching y'all's generation is how to cancel things out. 2 goes into 4 2 times, so this can become a 1. 2 times 1 is 2. 5 times 1 is 5. I get it in its simplest form. This is how my generation, your parents had to do it because we didn't have a calculator. 4 goes into 8 2 times, so I get 118. Here, you need to remember it's same, change, and then flip. Anytime you see dividing fractions, it's same, change, flip. So I keep it the same. I change this to multiplication, and I flip this to 3 over 1. So same, change, flip. 3 goes into 3. Both of those become 1, so it's 2 over 1, which is a 2. Same, change, flip, same thing here. 5 goes into 15 3 times. So that becomes 3/2 or 1 1/2. Reciprocals. Reciprocals are really easy. You just flip the numerator and denominator. When it's the reciprocal, we do not change the sign. That is when we do the negative reciprocal. That is when you have perpendicular lines. So when it's the reciprocal, the sign stays the same. Hope everybody had an easy time on that bell ringer. So we did perimeter and area of polygons yesterday. So now we're going to jump into circumference and area of a circle. And these are formulas that the ACT expects you to know. Most math tests expect you to know these. You've been doing these formulas for a while now. So circumference is literally the perimeter of a circle, but it's the distance around. And this is where that irrational number pi came from. Somebody figured out that there is a relation to the radius of a circle and the distance around, and they came up and found it was this number pi. Yeah, so when we calculate the circumference, the formula is 2 times the radius times pi, but we also know that 2 times the radius is the diameter. So you will use either one of these formulas depending on what information you're given. If you're given the diameter, just multiply it by pi. If you're given the radius, double it, multiply by pi. Now, always look at your answer choices when you have a circle, because you want to make sure that, are the answer choices in decimal form? So did they actually multiply by pi? Or are the answer choices in terms of pi? And when I say terms of pi, that would mean like this. 5 pi, that's an answer in terms of pi. And a lot of times the ACT will do this because you're supposed to be able to take the ACT without a calculator. So it's really hard to multiply by pi without a calculator. So they'll leave the answers like this, where you're doing basic math. And again, this can save you time on your calculations if you're not multiplying by 3.14. A lot of times they will tell you just to substitute 3.14. Again, I tend to just use the pi button on the calculator because it's going to be off a little bit, but it's close enough that I know which answer to circle. Here's an example. What is the circumference in meters of the circle that has a radius of 5? Since it's the radius, I'm going to double it. 5 times 2 is 10. And I slap a pi on there. So 10 times pi is 10 pi. Okay. Now, if it was multiple choice and it was a decimal, you can always estimate. Pi is 3.14, so 10 times 3 is 30. It's going to be a little more than 30. You need to know that the formula for the area of a circle is pi r squared. Excuse me. Now, I don't know how many of you ever noticed this. I did. Circumference is 2 pi r. This is how I remember them. And area is the exact same numbers, pi r, but instead of the 2 being in front, this is in square units. Look where the 2 goes. It goes from being in the front to now being an exponent. I had to memorize 40 formulas in a geometry class, and this is how I remembered it. It's the same terms, but since circumference is linear units, the 2's in the front, since area is in square units, it went up and became an exponent. Yeah. Maybe that'll help you. I don't know how to erase. Ah, there's an eraser. Yeah. See, you can always learn something new. Let's put it back on a pen. Let's go blue. So when you have area, unlike circumference, you have to have the radius. So if you're given the diameter, you need to divide it by 2. You cannot use the diameter in the calculations. You've got to divide it by 2. So again, circumference, you can use it. Area is going to be the space inside the circle. Circumference is the distance around. Now, our ACT example. What is the area of the circle with a diameter of 10? So since we're given diameter, we need radius. So we got to divide this by 2. So you need to know that the radius is 5. Now we don't double the radius, we got to square it. So this is going to be, ooh, bell time, 5 times 5, which is 25. So we square it, and then you just slap a pi on it. So that answer is, haha, C. Yep. All right, so you got 4 questions. Hit the pause button, set 4 minutes on your watch or on your phone, and answer the 4 questions. Again, hit pause, and then hit resume when you're done. All right, welcome back after those 4 questions. Hopefully you didn't use all your time and everybody did great. So let's check and see that you got every one of them right. Haha. So the first one, what is the area of the circle centered at the origin in the graph below? Use 3.414 for pi. Oh yeah, oh this is a bad one. Yeah, because is there, did I give you a graph for that one? Is this, Yes, you do have a graph. It's just not on here. I fixed it on y'all's. So if you look, okay, the radius in the graph is equal to what? 15. So you just have to do, this is where knowing your squares comes in handy. 15 squared is 225. So then you just need to do 225 times 3.14. I actually, 225 times 3 is going to give me 675. I'm doing all this math in my head because I do 2 times 3 is 600. 25 times 3 is 75. So the only one that's close to 675 is 706. I haven't picked up a calculator. And I know you all may not be math whizzes, but I know you can do $2 times 3 is $6 and 3/4 is 75 cents. Estimating works because none of the numbers are close. Here, what is the area of the shaded region? And the shaded region is half. So we calculate the area of the circle and divide by 2. It's got a diameter of 20 units, so that means the radius is 10. So 10 times 10 is 100. So it has an area of 100 pi. When we divide that by 2, we get 50 pi. Again, I really haven't needed to use my calculator. Here, this one's a little tough. Which of the following expresses the number of meters a contestant must travel in a 4-lap race where the course is a circle of radius or meters? Now, you're probably reading that going, they haven't given me enough information. I need more numbers. Okay, look at your answer choices. Because the first time I read it, I said the same thing. So I looked at my answer choices. And if you look in the answer choices, you got a variable in there. So they're not expecting you to have a full number. So the radius is not going to be given. It's in there. Okay. So they want me to do a race, and I'm going around this circle 4 times. Okay. So whatever this length is, I'm doing it 4 times. So it's literally going to be 4 times whatever that circumference is. That's what you've got to figure out. If I'm running around the circle, that's circumference. So that's going to be 4 times 2 pi times whatever that radius is. They've told me it's a capital R, and I see that in the answers. So 4 times 2 is going to be 8 times pi times the radius. So this is kind of like computer programming. When you tell me what that radius is, I can give you the rest. Next one, you've got circumference is 30 centimeters. They want to know what is the length of the radius. Some of you might have gone, ooh, 15, boom. No, it's circumference, not diameter. So let's do our formula. Circumference is 2 pi r. I'm going to give you a little hint. This gonna help you on the exit ticket. This is a clue to the exit ticket. So let's fill this in. 30 centimeters equals 2 pi times the radius. So the radius will be equal to 30 divided by 2 pi. 30 divided by 2 means the radius is equal to 15. Oops, I got ahead of myself. Is 15 pi. And I can take my calculator and do 15 divided by pi, and I can get a decimal. So I can get the actual length of the radius. And think about that. If I know the radius, can I turn around now and do the area? Because area is pi r squared. I just got to square the radius and multiply by pi, and I get the area. Is that a hint for an exit ticket? Because if I can take the circumference and find the area, could I take the area to find the radius to turn around and plug it into the circumference? Yeah, probably can. So that takes us to the exit ticket. And just like yesterday, I need you to stop my screen share. This says, explain how to use, if I give you the area of the circle, how can you turn around and give me the circumference? So the key here is, how do you find the radius? Because all you need to plug into the area formula and the circumference formula is the radius. And again, we just did a problem where I gave you the circumference and you found the radius. So you should be able to apply that to the area formula. If I give you the area, can you find the radius? And once you have the radius, can you give me the circumference? And again, show me step by step. You can use words, or I'm not a word person, I'm a math person. You can show it to me in math steps. You can write out the math, but how you do it mathematically, and that works for me. If you're unsure, take a picture, send it to me on Google Classroom or through an email, and I'll tell you if you're on the right track, if you need to add more. Show it to your parents. If your parents can follow the math, you know you're on the right track. If they go, I have no clue, they still may not have a clue, and I may say it's good. Yeah, so if your parents aren't math people, you may want to send it to me. Again, when you come to class, if you're still unsure, check with me. This is one people get zeros on because they don't give enough information, okay? You may understand it, but can someone reading it understand it, okay? So double check. Enjoy, have fun, and I'll see you when you get back to class.